Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on July 30th, 2025, just yesterday. This paper tackles automated program repair, which is the task of automatically finding and fixing bugs in code, and improves the repair success rate by up to 48.29%. The paper is titled Repair-R1, Better Test Before Repair, and its core idea represents a really clever shift in thinking. Instead of the usual fix-then-test approach, this method uses reinforcement learning to teach the model to first generate good tests that expose a bug, and only then try to repair it. Also, the authors shared their implementation on GitHub. If you head over there, you'll find all the Python scripts for their GRPO approach. This includes code for training, evaluation, and running the actual program repair, so you can really dig into how it all works and try it yourself. So to make this concrete, the first figure gives a really clear example. The task is to validate an email address, but the initial buggy code is too simple. It just checks for an @ symbol. The key insight is generating what they call a discriminative test case, which is a test that fails the buggy code, but passes the correct version. This is what helps the model truly understand the bug, and the charts below show this learning in action. We see the rewards for both code repair and test generation steadily increasing, while the model's output also becomes more concise. This next figure really lays out the whole optimization process. So the model gets a prompt with some buggy code. It then has two jobs. First, generate a test, and second, generate a patch to fix the code. This is where the reinforcement learning comes in. The model's output is evaluated and given a reward based on three things. First, a format reward, just to make sure the output is structured correctly. Second, a test generation reward, which is high if the test successfully catches the bug. And third, a code repair reward, based on how well the fixed code performs on the set of Oracle tests, which are like a master set of correct answers. This combined reward then optimizes the model, guiding it to get better at both tasks simultaneously. Building on that optimization framework, this figure shows the exact prompt used to guide the model. It's what's known as a one-shot prompt, which means it gives the model one complete example to learn from before it tries the actual task. You can see the example shows a simple buggy add function. Then, it provides several assertions, which are statements that check if the code is working correctly, and these are specifically designed to fail on the buggy version. Finally, it shows the corrected code. This whole structure teaches the model the desired test before repair behavior. Okay, so these pie charts really drive the point home. They show the correlation between generating a good test and fixing the bug, comparing the standard or vanilla models against the ones trained with this new reinforcement learning method. Look at the green slice. That's where the model succeeds at both tasks. For the vanilla models, this slice is tiny, but for the reinforcement learning models, it's dramatically larger. For instance, with the QN4B model, the success rate for both tasks jumps from just 8% to over 55%. This visually confirms that teaching the model to test first really helps it repair the code. Alright, so those pie charts gave us the visual, and this table provides the detailed proof. It breaks down the performance of different models across 4 coding benchmarks. We see results for the standard vanilla models trained with supervised fine-tuning, which is a common technique for training on a dataset of examples, and the new reinforcement learning methods. The key comparison is that final RL both row for each model group. This method, which co-optimizes both testing and repair, consistently scores the highest across the board, dramatically improving bug fixing, test generation, and test coverage. And these graphs give us a more nuanced look at that bug fixing performance. Each chart corresponds to one of the 4 benchmarks, and they plot what's called bug fix-it K, which is a common success metric. It tells us the probability that the model finds a correct fix within K attempts. As you can see, for all 3 model sizes, the more attempts they get, the higher their success rate climbs. This result shows that increased test time sampling, basically just letting the model try a few more times, really boosts its ability to find a correct patch. So, in conclusion, the key takeaway here is that by teaching a model to first generate good tests, it becomes much better at actually fixing the code. This test before repair approach, optimized with reinforcement learning, clearly leads to a deeper understanding of bugs and a significant boost in performance. That's it for this